Mice pie. Mice never tasted so delicious.
How many ways can you arrange a standard deck of playing cards? Today we are going to solve this problem. Let's see how. Firstly, let's see what a standard deck of playing cards means. In a standard deck of playing cards, there are 4 suits. There are clubs, diamonds, hearts, and spades. Within each suit, there are 13 cards. Ace, 2 to 10, Jack, Queen, and King. So in total, we have 52 cards in a standard deck. Now, the question is, how many possible arrangements are there? Right? Okay, you may pause this video if you want to give it a try. Please like this video and subscribe our channel to get more interesting math problems. Let's consider the solution. Now, firstly, we want to introduce a rule here, so-called multiplication rule. It states like following. If an experiment consists of m steps, say E1, E2 till En, and there are ni ways to perform step Ei for I equals 1, 2, 3, 4 till m, then there are in total n equals n1 times n2 times until nm possible ways to conduct this experiment. What do we mean by this multiplication rule? Consider this one. We have these steps 1, 2, 3, and m. We're going to firstly do step m, and then move to step 2, and then step 3, and then step m. Now there are n1 ways for step 1, to perform step 1, and n2 ways to perform step 2, and n3 ways to perform step 3. And finally, there are nm ways to perform step m. Now basically, this multiplication rule means, all right, their total number of possible ways to conduct this process consisting of these m steps will be what? N equals the multiplication of n1, n2 till nm. All right, now let's give a simple example here. Consider this example. How many ways are there to set up a 4-digit password? D1, D2, D3, D4, where the I can be from 0 to 9, integers from 0 to 9. So how to solve this problem? All right, we see that it is a 4-digit password. We can view it as an experiment consisting of 4 steps. All right, to choose a digit for the first one, and then the second, and then the third, and then the fourth. Now, how many ways to choose a digit for D1? As we can see, since D1 can be from 0 to 9, there are 10 possible ways for choosing a digit for D1. And similarly, this is also true for D2, so N2 equals 10, N3 equals 10, and finally N4 equals 10. So due to multiplication rule, there are n equals n1 times n2 times n3 times n4, which equals 10 times 10 times 10 and then times 10, which is 10,000. So there are 10,000 different ways to set up a 4-digit password. Now that's a lot of a lot of possible ways. So that's why when you set up a 4-digit password on your cell phone, you feel it is safe. Because anyone who try to break into your cell phone, they need to choose the correct one out of this 10,000 different passwords. Now, let's try to solve this problem. How many ways can we arrange a standard deck of cards using multiplication rule? We can think about this problem as an experiment. All right, we need stack all these 52 different cards, one on top of another. So in order to get a full arrangement, we need 52 steps, one step for one card. So first card, second, third, and then the 50 seconds. Now, let's think about this way. How many different ways, different choices do we have for the first card? How many are there at the beginning? Now, because at the very beginning, when we choose the first card, there are 52 cards there in the standard deck to choose from. So we have N1 for the first card, we have 52 different ways or different cards to choose for the first card. So N1 equals 52. Now, after the first card, let's consider the second card. Now, after choosing the first card, how many cards are left? Now, we see that there are 51 cards left for the second card. So there are 51 cards for the second card. So we have N2 equals 51. Similarly, after the first and second card, there are 51 cards left for the third card to choose from. So we see that N3 is gonna be 50. Now, if we continue this process to the very last card, now we see that N55, 52 is going to be just 1. So this is an arrangement. It consists of 52 steps, one after another. So due to the multiplication rule, we are going to have N equals N1 times N2 times N3 times till what? N52. Now that is 52 times 51 times 50 times till times 2 times 1. Now this product is denoted as 52 factorial. That means 52 times 51 times until 1. So there are 52 factorial different ways. That's our answer. That is the way how we solve this problem. Now, let's get a sense of how large this number is. 52 factorial equals this product. It is actually a really, really huge number. Let's just give some examples here. 3 factorial is 3 times 2 times 1, which is 6. 4 factorial, 4 times 3 times 2 times 1, that's 24. 5 factorial, that's 5 times 4 times 3 times 2 times 1, that's 120. And you can continue this one. 10 factorial is going to be given here. Now 20 factorial is approximately 1.433 times 10 to the power 18. And when you got to 52 factorial, it is approximately what? 8.066 times 10 to the power 64. What is that? How huge is this number is? All right, let's consider, do you know how many number of sand grains on Earth altogether? All right, if you assume a grain of sand have an average size, and you calculate how many grains are there in all the beaches and deserts in the world. Now, a rough guess is 7.5 times 10 to the power 18 grains of sand. That is the number of sand grains on the whole Earth. As you can see, it is just a tiny fraction of 52 factorial. So this number of arrangements for a standard deck of cards is just a huge, giant number. So next time we shuffle a deck of cards, just be aware that that arrangement you get might has never been appeared in history before, and may never happen again in the next billions of years. All right, that's how we can solve this problem. It's using what? The multiplication rule in counting methods. Now, can you solve the problem below? How many different arrangements can you make using the letters from the word great? That is G-R-E-A-N-T, great. Give it a try and leave a comment below. And don't forget to subscribe our channel. Thank you. Have a good day.